Welcome to the DIY Honda Garage channel. The DTC P0713 indicates an open circuit in the continuously variable transmission CVT fluid temperature sensor. This diagnostic trouble code is generated when the vehicle's computer detects a problem with the electrical circuit related to the transmission fluid temperature sensor, specifically indicating that a signal is not being properly received. The CVT fluid temperature sensor plays a crucial role in monitoring the temperature of the transmission fluid, which is vital for optimal transmission function. This sensor is typically located near the transmission itself and sends temperature data to the Transmission Control Module, TCM. If this sensor fails, it can lead to improper transmission operation, affecting vehicle performance and reliability. It is important to note that this DTC does not arise from mechanical issues within the transmission, reinforcing that the problem lies within the electrical circuit. Before beginning troubleshooting, consulting the general troubleshooting information is recommended for comprehensive guidance. The CVT fluid temperature sensor's primary role is to monitor the temperature of the transmission fluid and relay this information to the Transmission Control Module, TCM. This sensor is located in close proximity to the transmission to obtain accurate temperature readings. By measuring the fluid temperature, it ensures that the transmission operates within the appropriate temperature range, thus preserving the integrity and performance of the system. If the temperature gets too high or too low, the TCM can make necessary adjustments in fluid flow or transmission operation to prevent damage. Given that this code pertains to an electrical circuit issue, it is vital to focus on the connections and wiring associated with the sensor. A malfunctioning sensor will result in poor communication with the TCM, leading to decreased performance and potential long-term damage if not addressed promptly. Understanding the potential causes of DTC P0713 is crucial for effective troubleshooting. The primary cause is an electrical circuit fault, which could involve wiring issues or problems with the sensor itself. Loose connectors can create intermittent connections that may result in sporadic readings, contributing to the DTC being triggered. Additionally, a faulty CVT fluid temperature sensor is also a possible culprit. If the sensor fails to function, it will result in an open circuit that activates the DTC. Properly diagnosing the issue requires a detailed check of all electrical connections and sensor functionality. Be aware that this DTC does not arise from mechanical problems in the transmission, which helps narrow down your troubleshooting efforts to the electrical system. Symptoms associated with DTC P0713 can greatly vary, but the most common indication is the illumination of the check engine light on the dashboard. This warning alerts the driver that there is a problem within the vehicle system that requires attention. Additionally, you may experience transmission performance issues. For example, the vehicle may hesitate during gear shifts, or you may notice unusual noises while driving. Another symptom may include erratic temperature readings from the transmission fluid, which can either be consistently high or low and affect shifting performance. It's essential to heed these signs, as ignoring them can lead to further complications within the transmission system. To ensure the longevity and proper functioning of your vehicle, immediate attention to these symptoms is vital. In the first troubleshooting step for DTC P0713, begin by turning the vehicle to the on mode, which powers up the vehicle's systems without starting the engine. Next, use the Honda Diagnostic System, HDS, to check the parameters of the CVTF, Continuously Variable Transmission Fluid Temperature Sensor. Specifically, you are looking at the voltage output from the sensor. The normal threshold value should be more than 4.93 volts. If the readings align with this threshold, it indicates the current conditions match, confirming that the issue may be somewhere downstream. However, if the readings do not match, consider this a sign of intermittent failure, where the system may seem operable at times, indicating the need to check for poor connections and loose terminals. If any freeze data or onboard snapshots of the fault are recorded, attempt to replicate the failure under the same circumstances through more clarity on the issue. Step 2 in troubleshooting DTC P0713 requires turning the vehicle to the off or lock mode to ensure safety. After that, disconnect the solenoid wire harness A 8P connector to isolate the sensor. Once disconnected, use a jumper wire to connect terminal A to terminal B. Terminal A refers to the female terminal, number 7, of the solenoid wire harness A connector, while terminal B is the body ground. This step is intended to create a short circuit which will allow for a specific voltage reading that should enable further diagnostics. After making these connections, switch the vehicle back to the on mode. Utilize the HDS to again check the CVTF temperature sensor voltage, expecting it to show less than 0.07 volts. Depending on the outcome of this check, you will either proceed to Step 3 or Step 4. In Step 3, start by turning off the vehicle to safely proceed. After the vehicle is shut down, remove the jumper wire used in the previous step to revert back to normal testing conditions. Then, connect terminals A and B again. But this time, you'll utilize terminal A, the female terminal number 6 of the solenoid wire harness A connector, and terminal B, the female terminal number 7 of the same harness. After making these connections, proceed to turn the vehicle back on. As you monitor the CVTF temperature sensor's voltage output through the HDS, you are looking for a reading of less than 0.07 volts. If this condition is met, it indicates a faulty CVT fluid temperature sensor and signals that the solenoid wire harness A needs replacement. On the other hand, if you do not achieve this reading, the sensor is likely functioning correctly, which would necessitate checking for an open circuit in the wire connecting solenoid wire harness A to the TCM. Step 4 involves inspecting the TATF, transmission fluid temperature sensor line, for any open circuits. First, turn the vehicle to the off or lock mode to maintain safety. After this, disconnect the TCM 50P connector, which connects to the transmission control module. The continuity of the TATF wire, specifically between test points 1 and 2, will need to be checked. Test point 1 is the female terminal number 7 of the solenoid wire harness A connector, while test point 2 corresponds to the number 33 terminal of the TCM 50P connector. Ensure that the vehicle is in off mode and both connectors are disconnected while performing this test. If you find there is continuity, it indicates that the TATF wire is functioning correctly. At this point, consult any authorized service information regarding the DTCs or symptoms you are troubleshooting, or consider substituting a known good TCM for a further inspection. If the DTC clears after TCM substitution, the original TCM should be replaced. If there is no continuity, an open circuit exists and requires repairing the TATF wire between the solenoid wire harness A and the TCM. After completing the necessary repairs outlined in this troubleshooting guide, it is essential to perform a final repair verification. Begin by clearing the Diagnostic Trouble Codes, DTCs, from the vehicle's computer to reset the system and eliminate any outdated fault codes. Following this, take the vehicle for a test drive under various conditions similar to those that originally triggered the DTC. Monitor the vehicle's performance throughout the test drive and pay close attention to the operation of the transmission and any potential warning lights on the dashboard. After the test drive, recheck the system using the HDS to ensure no new DTCs have appeared and verify that the previous fault has not returned. This final step is crucial to assure that the repair has been effective. and that the vehicle is operating normally. Ensuring the transmission is running smoothly will lead to improved vehicle performance and reliability. Preventive maintenance is critical for keeping the CVT system healthy and avoiding DTCs like P0713. Regular inspections of the wiring associated with the CVT fluid temperature sensor can help catch potential issues before they escalate. This includes looking for signs of wear, corrosion, or loose connections, which can lead to electrical failures. Additionally, checking connectors for cleanliness and tightness ensures reliable electrical contacts and helps improve sensor accuracy. It is also prudent to routinely monitor CVT fluid levels and quality, as low or contaminated fluid can affect temperature readings and overall transmission health. Implementing these preventive measures contributes to maintaining optimal performance and can prolong the life of the transmission system. Scheduling consistent maintenance checks not only saves time and costs, but also enhances vehicle safety and reliability for long-term use. In summary, the DTC P0713 points to an open circuit in the CVT fluid temperature sensor, emphasizing the necessity for prompt and thorough troubleshooting. Identifying electrical issues quickly can prevent unnecessary damage to the transmission and enhance overall driving experience. This involves carefully checking connections and wiring, as mechanical problems are not the cause of this DTC. By actively monitoring transmission performance and being attentive to symptoms such as abnormal behavior or warning lights, you can act swiftly to address potential problems. Conducting regular maintenance further ensures the longevity of your vehicle's transmission system. Integrating these practices into your vehicle care routine will culminate in better performance, reliability, and peace of mind while on the road. Please like and subscribe to the channel. See you next time.